Hello, Algebra 1 students. It's Mr. Ford here with another homework tutorial. Haven't done one of these in a while. This is for 715, problems 61 through 66. 61 we kind of started during the first hour, but I'll kind of walk you through what's going on here. Drama Club found the best price for renting a fog machine is $38 every 3 days, which is why I got the days down here labeled with every 3 days. That's the number of days down here. And the price is going to be over here on the y-axis. Now we're making a step graph for this because what's going to happen is that every 3 days that go by, the price is going to go up by $38. So every 3 days, price goes up by $38. And then it stays that cost until the next time, and then it pops up and stays that way until the next time. So there is a step graph tutorial on your notes. If you flip back one page to the math notes right there, step graph is going to look something like this. So I think what's going on here is that first day is going to be $98. And I think that's because the one-time delivery fee of $60 plus $38 for the rental itself, that's the $98 that I'm using here. So for the first 3 days of this graph, it's going to be $98. And I'm just going to make a graph, a horizontal line kind of like that. And the idea here is that as soon as you hit that third day, let's put a big circle there, we're going to jump up another $38. 98 plus 38 is going to be 136. You can see I started to label this with an even amount, but I just kind of abandoned it after a while. The y-axis kind of has its own thing going on. So the next 3 days, it's going to be $136. Add another 38 to that, and you're at 174. And so on. You see the pattern develop right there. Every time you add another 3 days on, you go up by another $38, and your graph kind of looks like that. There you go. We'll do up for 3 weeks, I suppose. Actually, up to 3 weeks would be 21 days, but I'm going to stop because I don't care. Okay, 762. Use the clues in the graph at right to find the possible corresponding equation in a times b to the x form. This is exactly what we did today in class. So what you got to remember is that in y equals a times b to the x, a is going to be the starting value, or the y-intercept, and b is going to be the multiplier. So starting value is going to be the y-intercept, which is 4 in this problem. The multiplier is whatever number you multiply 4 by to get to that point. That is the point 1, 7 right there. So what I think you should do in this problem to find the b is take the 7 and divide it by the 4. And honestly, I wouldn't even go any further. I know this is 1.75, but who cares? Let's just use 7/4. Because I know that 4 times 7/4 is 7. So the equation will be y equals 4 times 7/4 to the x power. And that's all she wrote there. Pretty cool. Okay, question 763. Kristen's grandparents started a savings account for her when she was born. They invested $500 in an account that pays 8% interest compounded annually. Okay, so we've done a lot of this in the early parts of Chapter 7, but we did a little NWEA break, so I'll remind you how to do this. They invested $500 in the account. That's going to be your A in this problem, the starting value. The B is the 8% interest that they're going to be growing by. Now, because it's growing by 8% interest, we're going to use 1.08 for the multiplier. So using that information to put it together, the equation is going to be 500 times 1.08 to the x power. That's exactly what we want. After 1 year, it'll be 1 time 1.08. After 5 years, you'll multiply by 1.085 times, and so on. Question B, how much money is in the account on her 16th birthday? Well, all we got to do here is plug in 16 for x, because that means that many years have gone by. So this is going to be 500 times 1.08 to the 16th power. And this is 500 times 1.08, all raised to the 16th power. On my calculator, it looks like that's a pretty big number. Actually, it's not too big, 1712.97. So 1,712.97, I think is what I'm looking for the answer there. And then for this final question, question C, what are the domain and range of the equation that you wrote in part A? Well, technically the domain is all real numbers. Technically, it's all real numbers because you can plug any number in for this x right there. That's what we're asking is that, okay, what could x potentially be? X could be anything. There's nothing that stops it from being a problem. Although, I think the more I think about this, I don't think this is correct. I think the domain is positive numbers. Positive real numbers. Because you can't go negative in this world. You put the money in, $500 goes in the account, X is the number of years, that's always got to be a positive number. The range is also positive numbers. Actually, the range in this problem is going to be y values that are greater than or equal to 500. Because you can't possibly have less than $500 in the account. It's going to be $500 and it's going to grow from there. So the range in this problem is dollar values that are greater than 500. For 764, we're going to use our graphing calculators, or if you've got Desmos somewhere, we're going to graph these things. We're going to talk about, let's see, I think there's a typo on this, actually. I'm going to fix this in the Google Doc in just a moment, but this is supposed to be squared right there. That's supposed to be a second power right there. So we're going to go on our calculator, or you could use Desmos for this. We're going to graph two functions, x squared plus 3 and x plus 3 squared. Those are different graphs, so we're going to carefully do this. I did leave a note, use Desmos for this, because you don't have a calculator like this at home, but you could watch this video later on, or you could be following along here, x plus 3 to the second power, like that. So these are our two different graphs. Be careful when you're plugging them in to whether you're using Desmos or whether you're using this graphing calculator. Please make sure to plug them in correctly. These are two different ideas going on. Now I'm going to push the zoom button on my calculator, the middle of the top row, and I'm going to choose number 6 because I want to see this on a nice standard -10 to 10 graph, which is Desmos' basic too. There's the first graph, x squared plus 3, and then this is the second graph, x plus 3 squared. So as far as observations of this thing go, what are the similarities and differences of these graphs? And how do they compare to the graph of y equals x squared, which we're going to graph, I guess, also? I think the key takeaway for me, these are the same graph. But they are moved around different places, but moved around to different places. I want to point out, as your future Algebra 2 teacher, or maybe, who knows, let's actually go into the y equals menu and let's add on the graph of x squared to this, which will show up on black, or in black on this graph too. I think what's important is that x squared plus 3, the blue graph, is this black graph but moved up 3 spaces. So I'm going to make a note of that. Y equals x squared plus 3 has been moved up 3 spaces. I'm going to make my window a little smaller. And then looks like y equals x plus 3 squared has been moved left 3 spaces. This is a really big idea in Algebra 2. This is a preview question for a big idea going up, that you can take any graph and you can slide it to the left or right or up and down just by adding certain numbers, but where you add them matters. You can add them after the squared or within the squared. It changes it from left to right, up and down, but this is just setting the stage for that observation later on. For 765, we got some rational functions here to deal with. So honestly, if you know where these functions are in your calculator, you can just ask a calculator what these answers are, but we will not be doing that. We'll just be thinking about what the number is. This is asking us what number times itself 3 times is equal to -1,000. Well, the negative sign is a dead giveaway that it's got to be a negative number, because a negative times another negative will be a negative number. So we know it's got to be a negative answer to start off with. So as far as the number goes, what number times itself 3 times is 1,000? That's a pretty obvious 10, I think. So in this case, we're looking for -10. Because -10 times -10 times -10 would be -1,000. Question B is asking us for the cube root of 1/8. Same question. what number times itself 3 times is equal to 1/8? I mean, maybe you recognize the relationship between 2 and 8 that we've already used once today in the class, but this has got to be a fraction there. So I think the key here is it's got to be 1 over something times 1 over something times 1 over something, which is 1/8. And then you really just got to focus on the number, like that. And the number there is 2, 1/2, 1/2, 1/2. This is 1/2. Question C is asking us the same question as question A, only it's got to be a negative 125 when you're all done. So again, what number times itself? It's going to be a negative number, so x times x times x is 125, negative 125. In this case, you're looking for a negative 5. Negative 5 times negative 5 is positive 25, but 25 times negative 5 is negative 125. And then question D, this is the same problem, but now there's a fourth root involved. So the question changes a little bit because now it's asking, okay, x times x times x times x one more time. What number times itself 4 times is 81? The good news is there's only a handful of whole numbers out there that work. It's not 2, because 2 times 2 times 2 times 2 is 16. I think it's 3. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So this is 3, because 3 times 3 times 3 times 3 is 81. That's the idea. And then finally, we got some equations, so we're just going to dive right into it. For question A, let's combine our like terms together. We got 9a minus 3 equals 4a minus 3. The minus 3's can actually just cancel right out right now. We can remove them from both sides of the board. And this is one where you might think the answer is no solution, but there absolutely is a solution. There is a number you can multiply 9 and 4 by and get the same number. That's 0. If you keep going, normally algebraically, what we would do is subtract the 4a from both sides. And what we would get is 5a equals 0, and then we would divide the 5 on both sides and get a equals 0. So it works out no matter what you think. Question B. Here we got a distributive property in the front, so let's do that first. 8 times 3m is 24m minus 16 minus 7m equals 0, like that. Then we'll do 24m minus 7m. That's going to be 17m minus 16 equals 0. We'll add the 16 to both sides, and this gives us 17m equals 16. We will divide the 17 on both sides, and we will finally get the answer we're looking for, which is 16 divided by 17, and there you go. Not a whole number? Who cares? I don't even know what 16 divided by 17 is. Moving on. This is one of those questions where you might be tempted. You could get rid of the fraction by multiplying everything by 2. That's a really common strategy, but only having the one fraction there is not too big of a deal. So let's just do this one normally. I'm going to subtract 1 from both sides, first of all, to get the x piece by itself. That's going to leave us with x divided by 2 equals 5. And then we'll multiply by 2 on both sides, and we'll get x equals 10. And then question D. We have an absolute value equation, so right away, I know that before we even start this, there are going to be 2 solutions. Absolute value equations always have 2 solutions. Let's subtract 5 from both sides. This will give us the absolute value of x minus 3 equals 6. And now that we've got the absolute value by itself, now we want to split it up into 2 equations. The first equation is x minus 3 equals 6. But the second equation is x minus 3 equals negative 6. Leave that negative sign or leave that minus sign alone. It's the same. In fact, the entire inside of the absolute value stays the same every time, but we make it equal to the positive version of 6 and the negative version of 6. And then from here, we just add the 3 to both sides. So we got x equals 9, and we got x equals negative 3. There you go. And there you go. That is your homework tutorial for this one. I'm taking a little more time to explain things, so it's a little longer, but you'll be fine. Okay, keep it up. You guys are doing great. Let's push through to the end of the year. You're almost there. So I'll see you in the next video.